log properties. So these are going to work with the logarithms that we were working with last week. And only 3, I'm not going to give you more or anything like that. There's the product, the quotient, and the power. What I'm going to try to do here, I'm going to write these like the formal definition of the rule, and then I'll give you a little example with some numbers, okay? So the actual product property, product means I'm multiplying 2 things together. So this says log base b of m times n. You can break this apart into the log base b of m plus the log base b of n. So multiplied, when it's put together, you can break that apart with addition. And sometimes it depends on the question. Sometimes it's useful to break it apart. Sometimes it's useful to put it together. So we want to make sure we understand how to do both. So multiplication turns into addition when you break it apart. Okay, let me make up a little example. Let me think of a number. I'll just use plain log by itself. That means it's base 10, so I'm just going to use a common logarithm. Let me make something up. Let's say I pick the log of, I don't know, 24. If I could think of 2 numbers that would multiply, and there's several ways you could answer this. Can you think of 2 numbers that you would multiply together and get 24? 6 and 4. That's a perfect example. So I could write this as the log of 6 plus the log of 4. If I put that back together, you would do 6 times 4. Just as an example, we could do like 8 and 3, we could do 2 and 12, we could do 1 and 24. There's a bunch of different examples, but just as a little example there, if it's together as a product, you would multiply the 2 together. Anytime it's addition, like if you put it back together, you take the 2 values and multiply them together, anytime. Now, if multiplication turns into addition, what do you think division's going to turn into? Subtraction. So this is where you're going to use the subtraction. So a quotient means I'm dividing 2 things. So this is the log base b of m minus the log base b of n. So what I have there on the left side, that's called a single logarithm because I just have the log word written once. On the other side, that's called the expanded logarithm because I have multiple logarithms to illustrate the property there. Okay, now this one probably isn't necessary. I'm just going to make up a little thing. Like let's say we had the log of 3/4, just as an example. That would be equivalent to the log of 3 minus the log of 4. This, honestly, for the addition, it doesn't matter the order you put them in because when you put them together, you're going to add. It does matter for the subtraction. Whatever's in the top of the fraction, that has to go first. Whatever's in the bottom of the fraction, that has to go second. So that would have to be log of 3 minus log of 4. And if you guys wanted to check this on your calculator, I did common logarithms. You could check it on both sides. It would be weird decimals, but it would be equivalent. Okay, now the last one, this is called the power property. Now, power property means you're going to have an exponent on something in your logarithm. So this is log base b of m to the a power. Okay, I just think of this. This exponent is actually going to go back up and come in front of the logarithm when you apply this property. So it's the same as a times the log base b of m. So whatever your exponent is, if you have one, you can actually bring it down in front of the logarithm, get rid of the exponent, and that way it's multiplication, and we don't have an exponent then in the problem anymore. All right, so I'm just going to make one up with variables and numbers here, but like let's say I had the log, I don't know, let's say we had the log of like x to the 5th. Logarithm, I don't know, I didn't make up the name. I should Google that. Probably should know that, but I don't know why it's called a logarithm. Not a word I made up for sure. Okay, now here's what you can do. So just take that exponent and it can come down in front, and you could rewrite that as just 5 times the log of x. So that's going to be your power property. Just these 3. So multiplication splits apart into addition, division splits apart into subtraction, and then the power, if you have a power on something you're taking the log of, just put that in front of the logarithm. Okay, all I'm asking you to do in this first example is literally just tell me which property or properties are being illustrated by the statement. So this says log of 6 is equal to the log of 2 plus the log of 3. Which one of those three property or properties am I using there? Just product, done. This is, if I squish that back, I can't spell apparently, this is the product property. If I squish that back together, we do 2 times 3, that gives you 6. Okay, the second one, I've got log base b, I've got an x squared over y, and then that's a true statement. It says 2 times the log base b of x minus the log base b of y. What property or properties are we using to illustrate this sentence? Yep, there is more than one for this. Done. Quotient, that's the subtraction, and then that 2 here comes down in front, so quotient and power. So that has 2 properties there. So that's just identifying. Okay, now what we're going to do in this next example is we are going to squish these together as a single logarithm using the properties. Okay, now there's 2 ways these questions will be presented to you. Either write it as a single log or they'll call it expand. So we're going to focus on single log. If you see that in the directions, we're going to push it together using the properties. And you might use 1 property, you might use 2, you might use all 3. So my first example is going to use 2 of the properties. If you have a number in front of a log, that becomes an exponent on whatever is following that. Now, you absolutely don't have to write this in 2 steps, but I'm going to write this in 2 steps, 1 property at a time to show you guys where this comes from since it's pretty new to you. All right, so just, oh my goodness, my pen doesn't want to work. Okay, just applying the power rule. That first term would become log base 4 of x cubed, and then minus log base 4 of y to the 5th. That's absolutely just applying the power rule. If you can do this all at once, that's completely fine. If I have subtraction, when I squish it together to write my single logarithm, I'm just going to remember subtraction turns into division. Whatever comes first is the x cubed here is going to go on the top of my fraction. Whatever comes second goes on the bottom of my fraction. That's going to be y to the 5th. And then I just have a single log base 4 x to the 3rd over y to the 5th. Okay, now these next 2 each have 3 parts. So if these, I'm going to apply the power rule here real quick. So I've got a 6, so that'll be x to the 6th. I've got a 4 here. This will be z to the 4th. Don't worry about negative exponents if you've got subtraction. Don't worry about that. This is log of x to the 6th plus log of y minus the log of z to the 4th. If you don't have the little subscript, if you don't have the base, it's base 10, if you guys remember that. So just less writing here if we don't have that. Now this is important. If you've got like 3, 4, 5 logarithms, like I do have 3 here, you have to apply the properties as you read them from left to right. So this one is taking the log of x to the 6th plus the log of y. So first I would put those guys together. If it's addition, it's going to squish together with multiplication. All right, and then I have that minus log of z to the 4th. Okay, now here's the deal. When I further squish that together as a single logarithm, you're going to have that x to the 6th y, the whole thing, over z to the 4th. And again, if you want to do that in fewer steps, that's completely fine with me. I'm just trying to show you where it comes from. So I just applied the left to right as you read it, apply the product rule first, and then the subtraction, put z to the 4th under that entire thing. All right, and then I got one more. And then this one I'm going to ask you, because a lot of the questions will do this. If I look at the middle term that I have here, I have 1/3 log base b. So let me just, this is log a minus, if I just apply the power rule, b to the 1/3, and the last term would be c to the 2nd. If I just bring those powers up top here. Okay, now I want to ask you just real quick. If I have b to the 1/3 power, does anybody remember, this would be from our last unit, what is that equivalent to as a radical? Cube root, exactly. Okay, most of the time they write these answers with a radical instead of a rational exponent when you see them, so I just want to make you aware of that here real quick. Okay, so when I'm going to put this together, this has got 2 things that are kind of tricky. As you read this from left to right, this is going to take a and it's minus, so I'm going to have a quotient. So this would be a over, and I'm going to write this as a cube root of b. And absolutely do not worry about rationalizing anything at all in this unit. So if you get a radical in the denominator, just leave it alone. That's cool. Okay, now the next piece says plus c squared. So then I would take that, and addition turns into multiplication, so it'd be times c squared. Now, let me ask you this. Would the c squared end up in the top of that fraction or the bottom of that fraction if I simplified that? If I'm going to take a over cube root of b, I'm going to multiply that by c squared. Where would the c squared, would it be in the top of the fraction or the bottom? Anybody know? Okay. All right, algebraically, if I multiply by something that's not a fraction, right, it was just c squared, you can always turn it into a fraction and write it over 1. You do not need a common denominator to multiply fractions together. So if I have a quotient, which I did there, and then I'm going to multiply it by something, that something just goes in the top. So I would want to see this written log, this would be ac squared, the whole thing, over the cube root of b. That one's really tricky. But if it's subtraction first, you got a division, and then multiplication after that. That multiplication is going to go in the top of that fraction. Is anybody having a question? Yeah, that's why I was saying, don't worry about rationalizing anything in this unit. We're just not going to mess around with that. So if you get a radical in the bottom, no worries. Okay. Now, this set of questions, exactly the same. However, these all have numbers, and they're going to say evaluate. So this is going to be like a little review from what we were doing on Thursday, but we're going to first squish these together as a single logarithm. So let's just do this really quick. All right, addition turns into multiplication. So both of these are base 2. I'm going to do 4 times 16. This would be as a single logarithm. 4 times 16 is going to give me 64. Okay, so that's writing as a single log. Now, the rest of the question up there does say then evaluate, and this would be the type of question I'd want you to be able to do without a calculator, but feel free to use that lovely little yellow sheet. If you have to evaluate a logarithm, just set it equal to x. That allows you to change it to an exponential real quick and get rid of the log. So I'm going to swing this. The base of the log becomes the base of an exponent. 64 is going to stay where it's at. We're going to get rid of the log. That 2 is going to push the x up in the air to be in an exponent. And then you're just trying to tell me what that exponent would be. Does anybody know what x would be there? It's a nice number. 6, exactly. So my answer right here is 6. The reason is 64 is 2 to the 6th power. If you want to skip that step, that's fine. But you're just trying to figure out what that exponent would be. If you're having a hard time, try to write that number so it has the same base there. It's 2. 2 to the 6th power is 64. Okay. I'm just going to do these real quick because I feel like we're running low on time. All right, if I squish these two guys together, this is subtraction. So subtraction turns into division, log base 3 of 9 over 27. And if you can, try to reduce that. So this would be the log base 3, 9 over 27. Those are both divisible by 9. And so that fraction would reduce to just be 1/3. And then I want to, that's writing it as a single log. Now we're going to just evaluate real quick. So I'm going to get rid of the log by changing this to an exponential. So I have 1/3 equals 3 to the x. Anybody know what x would be there? It's a nice number. -1. And if you're like, I know that, cool, just write it. You don't have to show a bunch of work. If you don't understand that, just real quick, this would be 1 over 3 to the 1st. I could get rid of the fraction by writing that with a negative exponent. That'd be 3 to the -1 equal 3 to the x. If the bases are the same, that forces the exponents to be equal. That's going to make -1 my answer. If you've got a fraction, you're going to probably be dealing with a negative exponent. Okay. Now, I mentioned this to you guys on the front. This is going to be a power rule, so I'm going to do 1/2 power. 1/2 power is the same thing as what kind of radical? Square root. Okay, so this is going to be 4 to the 1/2. This first term is really going to be the log base 2 square root of 4. Okay, what's the square root of 4? 2. All right, so I've got two properties going on here. So I've got addition, that's going to be the product rule, and then I've got that 1/2 out in front, which is going to give me a square root. When we squish these together, you have adding turns into multiplication. So it's totally 8. This would be 2 times 4. Okay, now, and maybe once you guys get the hang of this, you might not have to write out a bunch of work. That's my single log. I'm going to evaluate this. I'm going to get rid of the log, leave the 8 where it's at. The base of the log becomes the base of your exponent. We're going to push that x up in the air. Anybody know what x would be for that question? 3. Done. If you know that, just be done. If you're like, what the heck? 8 is 2 to the 3rd power. You're trying. So 2 to the 3rd power is 8. I'm trying to rewrite this so they're the same base if I'm not sure about that. And so 2 times 2 is 4, times 2 again would be 8. So if these are both 2, then those exponents have to be equal. So then this has to be 3 to make that true. Like if this is just my equation, right? 8 equals 2 to the x. I have to plug in 3 to make that true. That makes sense? Okay. Sorry, I'm trying to rush through these. This one will be really quick, all right? But it is kind of weird. So subtraction turns into division. So this is log base 4. I'd have 64 over 16, which you can actually divide. 64 divided by 16 is 4. So this would be log base 4 of 4. Now, anytime your subscript and the thing you're taking to the log of, they're both 4 here. Anytime they're both the same, it will always be the same answer. This would say 4 equals 4 to the x. Does anybody know what this should be? If I just say that again? You don't have to rewrite it here, I promise. X is 1. 4, just by it, any number just by itself is to the 1st power. You could do 2, like 2 squared and then 2 to the 2x, but it would still be 1. But any number just by itself is to the 1st power. So keep that in mind. That's what I want to show you there. But literally, anytime if the base, like this is 4 and 4, if you had like 5 and 5, or if you had 6 and 6, that answer would be 1 every time. Okay, and I got one more. This, of course, has 3, so we got to be complicated here. Just remember, you got to apply these properties as you read them from left to right with the division and the multiplication. Okay, so this first term, if I just apply the power rule here, this would be 4 to the 3rd. Okay, minus log base 2 of 8 plus log base 2 of 4. So my first step here is to do the subtraction, which would turn into division if I squish that together. Okay, do you guys know 4 to the 3rd is 64? So I'm going to do 64, subtract, so divide by 8, and then I'm adding. So then I'm going to take that result and then multiply it by 4. I got to do the division first, though. So this would be the log base 2, 64 divided by 8 is 8. Then I'm going to multiply that by 4. So just as a single logarithm, this would be log base 2 of 32. That's my single log. Now, to evaluate, I'm just going to set this equal to x. I'm going to swing this. Anybody know what this is? 2 to the 5th? Oh, shoot. Sorry, 2 to the x. But 32 is 2 to the 5th. So your answer there should be 5 to evaluate that. Anybody have any questions?
Wait, so the answer is right now what power it is?
Yeah, but 5 would be the answer, for sure. Yep. I know that's a lot of work to work through it, but these are the types of questions they're going to ask you to do without a calculator. That's why I'm trying to write it all out. All right. Now, this example is actually going to reverse everything that we've been doing today. So you're going to have a single logarithm, and it's going to use the term expand. So that means I'm going to break it apart. You're going to have multiple logarithms here. I'm going to do this in 2 steps just so you can see it. All right, so this would be the log base 8. Okay, see if this is okay with you guys. Square root is the same thing as the 1/2 power. We're going to put a rational exponent when we expand, but we're going to put it back together. You're going to see the radical. And then I have a quotient here, so I'd be subtracting log base 8 y to the 4th. And if you can do this in one step, that's fine. I'm just doing it in two separate steps. Now, the other thing I can do here to further simplify this is the power rule reversed. So I'm going to bring those exponents down in front. So this would be 1/2 log base 8 of x minus 4 log base 8 of y. And that would be completely expanded. I just did it in two steps. So if you can do it in one, that's completely fine. But I'm applying there the power rule and then also the quotient. And this last one, I put this on here on purpose. So this is a product, right? But you actually have 3 different things being multiplied. You have 4, you have a, and you have b cubed. So I'm actually going to have 3 separate logarithms when I write this. And people, sometimes they mess that up. If there's a number there, they don't give it its own log. But if I break this apart, multiplication breaks apart into addition. So this would be log of 4 plus log of a. And then the only thing that has that power is the b to the third. And I'm just going to do that. I would have a 3 out in front of this last term, the log of b. But all those would be added together because it's a single product. The other thing I'm doing there is the power rule on that b to the third. So I just have a 3 in front of that. Does anybody have any questions? Okay, I put these ones at the bottom. These are like straight up off the SAT. So there is a no calculator section that will give you the log of something, and you're like, what are these garbage numbers, right? These look terrible, right? Can somebody grab that for me? Thank you, thank you. Okay, let me show you this just real quick. So if I have the log of 4, right? If I don't have a subscript, it is assumed to be base 10. That's called your common logarithm. And if I actually solve this, I'd have 4 equals 10 to the x. This is not a question I would have you do without a calculator because these are nasty numbers. But basically what that means is if I do 10 to the 0.6021 power, that would be equal to 4. So a lot of the times they're not nice answers like the questions I was asking you to do without the calculator. But that's why you got these weird decimals. But what they will give you is these decimals, and this will be like a non-calculator question, and they'll ask you to use the log properties with those decimals to answer these. So if I give you log of 20, how could you use like the log of 4 and log of 5 with our log properties to maybe rewrite that and answer that question? Exactly. We're going to add them together. We're going to add them together. Okay, so by your product property, this would be the same as the log of 4 plus the log of 5, right? If I break it apart, if I squish it back together, we're going to multiply 4 times 5. Well, if they give me these decimals, it's a little annoying, but I could do this if I didn't have a calculator, just add these decimals together. That's what you would do. You just got to think of a different way to write it with what they give you in the directions. Okay, what about log of 25? How could I use the information they gave me in the directions to do that without a calculator? Oh. Go ahead. Okay, so 25, right, is 5 times 5. So I could do log 5 plus log 5. Can anybody, there's actually another way you could do this. Is it? Yes. Okay, you could also do, right, 5 squared is 25. You don't have to write all that out, but we could then use the power rule and just do 2 log 5. Either way, we would take 0.6990, add that together twice, or we could do 2 times that 0.6990, give us the same answer. Okay, now, this last one's the weirdest. So you're like, Miss Grody, you're an idiot, and you didn't put anything about log of 1 in the direction, so how am I supposed to do this? Okay, so I'm going to show you. So I'm going to apply the quotient rule here real quick. So I would write log of 1 minus the log of 4. And I'm just going to come down here at the bottom and show you this. Okay, doesn't matter what the base is. If I just have a plain log, that means it's the common log. So if I have the log of 1, if I actually evaluated that, so I'm just going to set that equal to x, I'd have 1 equals 10 to the x. Okay, doesn't matter what the base is, this would be the same answer every time you do the log of 1. This number, any number to this power is 1. You know what x would have to be there? 0, yes. All right, any number to the 0 power is equal to 1. So if I had like log base 4 of 1 or log base 100 of 1, every time that would be equal to 0. So even though I didn't give you that in the directions, the log of 1, no matter what the base, is always equal to 0. So then for this one, I would just do 0 minus that 0.6021, which would just be negative 0.6021, and that would be the answer. So just showing you guys a couple of things.